Assalamualaikum and hi everyone. Now we continue topic 9 differentiation, lecture 2 of 4, part 4 of 5. At the end of the lesson, students should be able to find the derivative of a functions. The first one, functions ax and ex, that is exponential function. Number 2, ln x. So we want to differentiate three types of function here. First one is exponential, second one is logarithmic, and third one is trigonometric. This is our objective. So the first one, the function that we want to differentiate is exponential function. Recall back, exponential function is any function that is in the form of y equals to a to the power of x. This is the simplest form of exponential function or index function. So the simplest form is a to the power of x. So now we want to differentiate. So differentiate, the symbol is ddx. So differentiate y is equals to differentiate ex. We differentiate left side and right side. Differentiate y with respect to x is dy dx. Okay, differentiate ax. So how to differentiate the exponential function here? So the answer is you copy ax, then multiply by ln a. Okay, this is the answer. So how to prove? Okay, take a look at the proof here. If given y equals to ax, you need to take ln both side of both side of the equation. Then you will get ln y is equals to ln a to the power of x. Okay, please take note, when you take ln both side, we can apply the rule. So x will we can bring x in front. So ln y equals to x ln a. Okay, so we continue the next page. Then ln y equals to x multiplied with ln a. Then how to differentiate ln y? Now we differentiate both sides. Differentiate ln y, and you also differentiate on the right side, that is x multiplied by ln a. Differentiate y, this is implicit differentiation. Okay, implicit mean you want to differentiate a function that is not in terms of x. Now y is a function not in terms of x. So how to differentiate ln y? So differentiate ln y is 1 over y. Then you need to differentiate y itself. Differentiate y, d dx y. Differentiate y, dy dx. Okay, please remember, differentiate y, dy dx. So we have dy dx here on the left side. On the right side, you can solve by let x as a u and ln a as a v. Okay, u equals to x, so u prime equals to differentiate x 1. Then what is v? V equals to ln a. Please take note that ln a here is a constant. There is no x here. Ln a is a constant. So what is v prime? Differentiate constant 0. Okay, so we cross here. So by using product rule, we have x multiplied with 0 plus ln multiply with ln a multiply with 1. Okay, now this one is 0, so we get 1 over y dy dx equals to ln a. So finally dy dx equals to y multiply with ln a. So substitute back, what is y? Y equals to ax. Okay, so this is the conclusion. If given y equals to a to the power of x, so dy dx is equals to a to the power of x multiply by ln a. Okay, what about if we have a scalar here? Differentiate a to the power of mx. We have a scalar m here. So the derivative of a to the power of mx is, you have to copy a to the power of x, then differentiate mx. The answer is m. Then don't forget to multiply with ln a. So we have three things you have to consider here. Okay, firstly you need to copy what is the exponential form a to the power of mx, then differentiate mx. The answer is m. Then you have to multiply with ln a. Okay, for a simple exponential function e power of x, the derivative of ex is equals to ex. Okay, so we move to the second one. If m is a scalar, then the derivative, that is d dx e to the power of mx, is equals to mex. You have to copy what is the function that you want to differentiate, that is e to the power of mx. Then you need to differentiate mx. The answer is m. Then you have to bring m in front. Okay, or another way of writing is, if y equals to e to the power of mx, differentiate left side means differentiate y, you will get dy dx. Then differentiate on the right side means you have to differentiate e to the power of mx. So the answer is e to the power of mx. Then you need to differentiate the power here, means differentiate mx. Okay, so followed by the derivative of d dx, differentiate mx. Okay, so differentiate mx, the answer is m. So you need to bring m in front. Okay, so you copy paste the function m e to the power of mx, differentiate mx, the answer is m. But when you write the solution, the answer is, you have to bring m in front, m e to the power of mx. Okay, as given here. Okay. Okay, we will continue with the derivative of a logarithmic functions. So the natural logarithmic function is differentiable for all x more than 0. So recall back, what is the natural logarithmic functions? The natural logarithmic function is any function to the base e, that is ln x, log base e. So if you are given a function y equals to ln x, okay, so what is dy dx? Dy dx is equals to 1 over x, or you have to memorize this formula. Okay, so how to prove? If given y equals to ln x, we change from log form to exponential form, ey equals to x. Then differentiate both sides with respect to x. So now differentiate, or d dx, differentiate ey is an implicit differentiation, because we want to differentiate y, a function in terms of y, with respect to x. So the answer is ey, and differentiate y itself, differentiate y is dy dx. So you must follow it by dy dx. So that's why I get this one. Differentiate x, the answer is 1. So we get dy dx equals to 1 over ey. Therefore, d dx ln x equals to ey. What is ey? X. What is ey? X. So the answer is, differentiate ln x is equals to 1 over x. You have to memorize the formula. Okay.